is the first country in the world to land a spacecraft near the moon's south pole.
Ever wondered about the moon's hidden mysteries? Well, renowned physicist Michio Kaku recently unveiled shocking revelations from India's ISRO lunar mission, Chandrayaan-3. This mission unearthed lunar water ice, a potential resource for future lunar endeavors, including drinking water, breathable oxygen, and fuel. But that's not the end of the story. Chandrayaan-3 has also made several other remarkable discoveries on the lunar surface that have sent shockwaves throughout the scientific community and space enthusiasts worldwide. In this video, we'll reveal what Chandrayaan-3 has discovered so far, its significance, and much more. Stay with us and let's get started. Before we dive into the incredible discoveries made by the Vikram lander on the moon's surface, it's important to watch a truly breathtaking video. This video captures the Pragyan rover making its descent onto the lunar surface, and it was filmed by Vikram's special camera, positioned on its upper side. This camera serves the purpose of helping Vikram lander keep an eye on its surroundings and communicate with the Pragyan rover. In the video, you'll see the Pragyan rover gracefully rolling down a ramp that extends from Vikram's underbelly. It's a slow and cautious descent as the Pragyan rover carefully approaches the moon's surface, while Vikram lander looms in the background, keeping a vigilant watch. As you watch, you might also hear the sounds of beeps and voices emanating from the Mission Control Center, providing critical updates on the descent's status. It's important to note that the team back on Earth doesn't have immediate control over the lander or the rover. The vast distance between our planet and the moon means that it takes roughly 1.3 seconds for a command to travel from Earth to the moon and another 1.3 seconds for a response to reach us. Due to this communication delay, the lander and the rover are pre-programmed to execute this complex operation autonomously, relying on their built-in computers and sensors. They must rely on their own intelligence and capabilities to ensure a safe and successful landing on the moon. This video stands as a testament to the remarkable synergy between the Vikram lander and the Pragyan rover, working together seamlessly to accomplish this historic feat. Following the successful lunar landing, the Pragyan rover captured an astonishing image of the Vikram lander standing tall on the moon's surface. This image was taken using the Pragyan navigation camera positioned on its front side. And that's not all. There's another video that showcases how the Pragyan rover skillfully navigates the lunar terrain and avoids potential hazards on the moon's surface. We'll delve into the details of this in the upcoming section. But for now, let's concentrate on this remarkable footage of the Pragyan rover making its descent to the lunar surface. In this image, you can see the Vikram lander standing upright, firmly supported by its four legs, positioned on a flat area near a small crater. Notice the main engine at the bottom, which played a crucial role in slowing down the descent and ensuring a gentle landing on the moon. This image serves as undeniable evidence of India's triumphant moon landing, an achievement not easily attained. In fact, only 3 other nations, Russia, the USA, and China, have achieved this remarkable feat before. Landing on the moon demands pinpoint precision in timing, navigation, and control of speed and altitude. The consequences of any error or malfunction during this phase can lead to mission failure or even a disastrous crash. It's no wonder that landing on the moon is often referred to as the most challenging aspect of any lunar mission. This image we're looking at isn't just about marking a successful lunar landing, it's also a heartfelt tribute to a true legend in the world of space exploration, Vikram Sarabhai. He's often called the father of India's space program, and for a good reason. Back in 1969, this visionary scientist laid the foundation by founding the Indian Space Agency. He didn't stop there. He kick-started numerous space projects across India, but his pioneering spirit extended well beyond space. He made significant strides in fields like nuclear physics, cosmic rays, meteorology, education, industry, and social development. Now, let's shift our focus to another fascinating video, this time featuring the Pragyan rover's maneuvers on the moon's surface. This remarkable footage was shot by the Pragyan rover itself using its trusty navigation camera. The video showcases the Pragyan rover in action as it skillfully navigates the lunar landscape, all while being powered by the energy of the sun through its 6 wheels. The Pragyan rover is not just an ordinary vehicle, it's the star of the Chandrayaan-3 mission. Its primary mission is to explore the lunar South Pole region and conduct a wide array of experiments and measurements. With the ability to roam up to 500 meters from the Vikram lander, it communicates not only with the lander but also with Earth via radio signals. However, don't let the simplicity of moving on the moon's surface deceive you. It's no walk in the park. The Pragyan rover faces a series of daunting challenges as it explores the lunar terrain. These challenges come in the form of low gravity, uneven terrain, dust particles, and extreme temperatures. Let's break down how the Pragyan rover tackles each of these obstacles. First, there's the issue of low gravity. On the moon, gravity is just about 1/6 of what we experience on Earth. This means the Pragyan rover weighs significantly less on the moon than it would back home. Sounds great for jumping higher and farther, right? Well, it is, but it also means less traction and stability. To handle this, the rover boasts a special suspension system that lets it adjust its height and tilt based on the lunar terrain. Plus, it has a maximum speed limit of just 1 centimeter per second to steer clear of losing control or tipping over. Next is the moon's uneven terrain. The lunar surface is rough and rocky, featuring countless craters, hills, and valleys. Navigating such challenging terrain isn't a walk in the park for the Pragyan rover. To conquer this obstacle, the rover relies on some pretty advanced navigation tech. It uses sensors, cameras, and clever algorithms to map out the landscape and plot the best course while avoiding obstacles. It's like having a super smart GPS for the moon. Additionally, the rover is equipped with a hazard avoidance system that can spot and steer clear of potential dangers, like massive rocks or steep slopes. Next is the moon's notorious dust particles. These tiny, sticky particles blanket everything on the moon's surface. They pose a real threat to the Pragyan rover's instruments and components. For instance, they can block the rover's solar panels, which supply it with power, or even mess up its cameras, which provide crucial vision. To beat this challenge, the rover comes prepared with a nifty dust protection system. This system employs brushes, blowers, and heaters to ensure that its instruments and components stay free from dust buildup. Lastly, we have temperature. The moon's temperatures swing wildly, depending on whether it's day or night or if it's basking in sunlight or shade. Temperatures can plummet to -156 degrees Celsius during the frigid lunar night and skyrocket to 121 degrees Celsius during the scorching day. Such extreme temperature shifts can wreak havoc on the rover's instruments and components, potentially causing damage. To tackle this hurdle, the rover features a top-notch thermal control system. This system uses insulation, radiators, and heaters to maintain the rover's temperature within safe limits, ensuring it can function effectively regardless of the lunar weather. As you've seen, the Pragyan rover is no ordinary machine. It's got brains and brawn, and it's built tough to withstand the moon's rough conditions. But it's not just a robot. It's curious and adventurous, always eager to explore new, uncharted corners of the moon. This little machine is on a mission to uncover the moon's secrets, and it's doing a remarkable job at it. Now let's shift our focus to something rather fascinating, a graph that tells us about the chemicals found in a piece of lunar soil. This data comes from Pragyan's laser-induced breakdown spectroscopy, LIBS, instrument. It might sound fancy, but it's one of the main tools the rover uses to figure out what's in the lunar dirt. Here's how it works. LIBS uses powerful laser beams to zap tiny bits of lunar soil. When the laser hits, it creates super hot and tiny bursts of light called plasma. The instrument then catches this light and looks at its colors to figure out what elements are in the soil. Now, this mission has a specific goal: to study the soil in the South Pole region of the moon. This is a distinctive area with characteristics that vary from other parts of the moon. This region is of immense interest for various reasons, as pointed out by Michio Kaku. He emphasized its significance, describing it as a historically and scientifically intriguing spot. Many nations are vying to explore this region, as it has the potential to serve as a base for future explorations. Furthermore, the discovery of water at the moon's south pole holds paramount importance for future missions. This water could potentially serve as a valuable resource, providing fuel for rockets and spacecraft. as explained by Michio Kaku. Analyzing the lunar soil composition yields valuable insights into the moon's origin, evolution, geological processes, and activities. Interestingly, the analysis results presented an unexpected revelation: a substantial presence of sulfur in the lunar soil of the South Pole region. Sulfur is a vital element for life, forming a part of various biological molecules like amino acids and proteins. Additionally, it is a key component in volcanic activity, frequently found in magma and lava. Sulfur's presence also hints at potential meteorite impacts, as specific types of meteorites contain this element. This discovery is not just exciting, it's genuinely intriguing, as it has the potential to reshape our understanding of the moon and its history. Moreover, it opens up new possibilities for future lunar exploration and even colonization. Now, sulfur isn't the sole element uncovered in this crucial lunar region. The Pragyan rover also detected several other elements on the moon's surface, including magnesium, aluminum, silicon, calcium, titanium, iron, and sodium. According to Michio Kaku, these elements hold essential keys to understanding the moon's geological history and how it has evolved over time. As for the Vikram lander, it has played a significant role in this Chandrayaan-3 mission, and it's worth noting that it also recorded movement on the moon. However, it has been placed in sleep mode after successfully accomplishing its scientific goals. You might be wondering why it was put to sleep. Well, this decision is closely linked to understanding the temperature of the moon's surface, a parameter that was carefully measured using Vikram lander's CHASTE instrument. CHASTE, which stands for Chandra's Surface Thermophysical Experiment, is a scientific gadget placed on the Vikram lander. It serves the purpose of measuring the temperature characteristics of the lunar topsoil around the pole. By checking the temperature at various depths below the surface, CHASTE can craft a thermal map of the moon's hidden layers. This is a major aim of the mission, especially in the distinctive South Pole region, which differs from other parts of the moon. The findings from CHASTE's measurements tell us that temperatures in the South Pole region fluctuate dramatically, ranging from a bone-chilling minus 156 degrees Celsius at night to a scorching 121 degrees Celsius during the day. This solidifies the fact that the South Pole area is among the moon's coldest and hottest zones, presenting significant challenges for both survival and exploration. This leads us to why the lander was designed to function for just one lunar day. It helps it endure the freezing cold lunar night. These lunar days and nights last up to 14 Earth days each, with nighttime temperatures plummeting to a staggering minus 183 degrees Celsius. Such extreme cold can freeze up the rover and landing module's instruments, rendering them inoperative. The Indian Space Research Organization has shared that the rover's instruments have been switched off, and the data it gathered has been sent back to Earth through the lander. At present, the battery is fully charged, and the solar panel is aligned to catch the first rays of sunlight, expected on September 22, 2023. The communication receiver is kept active, with hopes that it will wake up successfully for another round of tasks. However, it's uncertain if Pragyan can be reactivated. If it can, its mission will involve seeking out water ice and traces of hydrogen, valuable resources that could be used to produce water and rocket fuel. Meanwhile, India is also embarking on an exciting mission to study the sun in unprecedented proximity. A bit over a week after India made history by landing on the moon's South Pole, they've taken another big step in their space exploration journey. This time, they've sent a rocket to study the sun, which adds yet another impressive achievement to their growing space program. The spacecraft, known as Aditya L1, lifted off from the Sriharikota Space Center in southern India. Its mission: to get a closer look at the sun from a spot about 1.5 million kilometers, 930,000 miles, away from Earth. This spot, known as L1, gives an uninterrupted view of the sun. If all goes as planned, India will be joining a small club of countries that study the sun. The likes of NASA and the European Space Agency, along with China and Japan, have all sent probes to explore the sun's mysteries. And why do they do it? Well, the sun's behavior has a big impact on Earth, other planets, and space itself. For instance, scientists think that Mars, which might have once been a friendly place for life, turned harsh due to the sun's solar winds messing with its atmosphere. Now, the Aditya L1 mission aims to unlock some of the sun's secrets, like understanding the strange phenomenon of coronal heating. That's when the sun's upper atmosphere, called the corona, stays super hot at millions of degrees, way hotter than the layer beneath it. The scientists behind this mission are hoping to gather some truly unique data that no other mission has provided before. According to Sankara Subramanian K., the principal scientist of the mission, it will help us understand the sun's dynamics and the inner heliosphere, which is crucial for our technology and space weather. India's space program has been on a roll for about 2 decades now, and it's picking up steam. Their achievements, like sending 3 missions to the Moon and 1 to Mars, have been a testament to their technological progress. And they're not stopping there. They've got plans to send astronauts into orbit, possibly by 2025. So, India's space journey is definitely one to watch as it aims to become a major player on the global stage. Thanks for watching. For more thrilling videos, don't miss the next video that you on your screen.